Hello, everyone. My name is Torgersen. I'm joining you from my cozy home office in Seattle that you see here behind me. I'm really excited to be at MS Stage this year, even though I'm joining you from pretty far away. And just a very few words about myself. I'm an architect at Microsoft, and my day job is to be the lead designer of C Sharp. So C Sharp is pretty much all that I can talk about. And so why don't we go do that? So I'm going to start out here in one of my favorite web browsers. We have here the documentation site for C Sharp that is actually excellent. And I encourage you all to go here to learn more about what's happening in the language. There's a What's New in C Sharp tab here that even has the versions of C Sharp that aren't out yet. This is C Sharp 12 that I'm going to spend most of my time talking about today. And it's as it's not out yet, there's still like previews and so on. Whenever features are in preview, means I can show them, but it also means that you can actually go try them yourself, and you can go read more about them here. But only a few more weeks, and you can officially get the official release of C Sharp 12 as well. So I'm excited for that. I'm excited to hear what you all have to say about it when you get it in your hands. I want to point out also here briefly, if you're interested in how we think about how we evolve C Sharp, like what new features should we put in, why should we do it, what are the objectives of C Sharp's continued evolution, go check out the C Sharp language strategy here. It's a pretty terse statement of intent, if you will. This is how we think about our role as we evolve C Sharp. If you're interested in following along, there's a nice feature status page here on GitHub. Did I mention that we're open source? The C Sharp compiler is implemented on the GitHub site called .NET Roslyn. And one of the things here is that you can see what we're currently working on as in implementing. We already finished our work-ish on C Sharp 12. And that's why it has its own category down here. And some of these features we'll touch on just in a minute. But you can already see on the working set here that there are some things in flight that are likely to make it into C Sharp 13 or maybe the following release. But those are the things that are currently in the works. So that's a good way to get an overview of what's being focused on by the implementation team. And if you're interested in the nitty-gritty of the design, then the language design for C Sharp has its own GitHub site. And everything we do related to C Sharp language design happens in the open right here. So this is where you can go in and see the notes from all the design meetings that we have. You can see all the proposals that are currently being worked on and the ones that have already been completed. You can see new ideas being discussed here under discussions, and when they get firmed up a little more, they become issues and become fleshed out with a specification and discussed by the C Sharp language design team. Oh, I know this guy. So if you really want to kind of deeply engage in what happens with C Sharp over time, that's a good place to go. There's a lot of community participation, including features that are designed and implemented by people who do not work for Microsoft. So it is, there's broad participation here. But there's also a lot of volume, so it's not for everyone to, you might easily take too much time away from your day job if you get sucked into this. This is a very high activity site. So with that, I'm going to go to my favorite slide tool, which is Visual Studio. And we're going to spend the rest of the time pretty much here. We might look at a slide or two towards the end, but they will have code on them too. So it'll kind of be the same general idea. And let's talk about some of the features that are coming into C Sharp 12 and that are almost out now and ready for you to grab. I'll start with just a little palette cleanser of a feature, if you will. Every now and then, you realize that there's something in C Sharp that you've been stubbing your toe on forever. It's just this little nuisance, but why? And we always try to fix a few of those with every release. We probably introduce some new ones as well. So the balance remains the same, but one of those that we fixed in C# 12 is this weird thing that when you have a using alias, you have to put a named type. It has to be like a type with a declared name in a namespace somewhere. So you can't just say using grade. First of all, you can't say using grade equals decimal, because any other usings that we apply, they don't apply to this using. Like usings only apply after all the usings. So that's a little annoying. But up until recently, you couldn't say this either. You couldn't even use a keyword type. And we changed that so that any type syntax is good here. So now you can just use int and decimal and all those types that have keyword names, for instance. But other type syntaxes are allowed here as well now. So you can have, for instance, you could have tuple types. You could say it was a decimal and a string, and you can use tuple element names. So decimal, grade, string, subject, for instance, would now be a valid thing. There was no way you could say that before. We can even actually have pointer types. It's not a good place to have a pointer type here, but if we just, let's take it all the way down to decimal. And now the pointer syntax is valid. Now, you can only do it if you have an unsafe that is, and actually, if you put the star after, you can see I don't use pointers much. We have too many safe features in C#. So if you put the star after, and you declare the using itself as an unsafe context, then you're also allowed to abbreviate pointer types, just in case anyone's still into that. But let's just stick with regular decimals for now. So this is the kind of thing, like we just improve these all the time. Nobody typically realizes that we made these improvements. It's just that a bunch of people stop being annoyed by the things they can't do. So this is sort of like just removing little nuisances in the language. But of course, most features are on a much bigger scale in C#. In C# 12, we have two that I'm going to show you that are probably the most significant in terms of how many people will find use from them and how much they can impact your code if you choose to use them. So the first one I'm going to talk about is primary constructors. And that's a feature that that's already halfway in C# and we're just finishing the job. So primary constructor is this syntax here where you can put constructor parameters directly on a type instead of having a dedicated constructor declaration inside of your type. We already have that in C#, but only for records. And for records, records are these opinionated classes and structs that are all about representing data. And so when you do this on a record, you get all kinds of extra stuff. You get and what you get with the primary constructors is that all the primary constructor parameters also become properties, public init only properties. So GPA is not a good example because I declared that one, but there you see grades, ID, they all automatically become members as well. So that's great for records, but it's not great for all classes and structs. Like if you do more classic object-oriented programming, you want to encapsulate some data. You may not want to expose it in a public property. You may not want to expose it at all. You may want to keep it internal forever and so on. So for primary constructors to be generally useful outside of the opinionated world of records, we need them to not expose members, but they can still be useful. So what you can do now, as of C# 12, is you can put a primary constructor on a normal class, a non-record class here. And you'll see a few things. The primary one of which is that the members are no longer generated. So I can't say .id anymore. If you look in the list here, they're all gone. Like I can take GPA, which I'm explicitly declaring, and that's that. So the parameters are now only parameters. And in fact, to celebrate that, we should go and give them proper parameter names and not have these uppercase names here. So let's go and do this. Grades needs to be downgraded here, so to speak, as well. What can you do with them then? Well, the nice thing about primary constructor parameters is that they're in scope throughout the whole class, right? So if I want to expose, let's say I do want to expose let's say the name, for instance. I could choose, for instance, to declare it as public string name. Then let's say we want it to be an auto property. And then I can initialize it with the parameter that came from up there, which makes sense, right? Because initialization happens during construction. So you can imagine that we just sort of like put the initialization of this into the constructor that is generated from this primary constructor syntax here. But we can do more. We could also, let's say we want to expose ID differently. So instead of making it an auto property with its own storage, I'm going to give it a getter body that simply always returns ID. So I'm using the parameter not just to initialize, but I'm using it inside of the logic of one of the members, one of the function members of the class itself. And that actually works too. So somehow, even though ID is a constructor parameter, it gets kept around if necessary. And the way we do that under the hood is that if you do this, we stash it in an extra private field that we generate with a compiler mangled name, so that when you evaluate it later, we can fish it out and give it to you. So primary constructors are really useful like that. I should also mention that you might be thinking, okay, so what if I want to call a base constructor? Can I do that? Yeah. So if you have a base class, let's say we have, person. We do have a person class somewhere in my hidden part of this project. When you give a base class, you can actually also give it arguments. So in this case, it looks like it takes a name. So I can take the name that I got in as a primary constructor parameter, and I can pass it along as a constructor argument right up here in the header of the class as well. So it kind of fits together neatly. You also notice that there's an explicitly declared constructor here as well. So what about that? Like, what happens when you have another constructor? This is just a convenience one that doesn't take the grade array. Well, it's fine. You can have as many other constructors as you want, but they have to directly or indirectly call the primary constructor. That's part of why we use the name primary constructor. Everyone has to call it. It is the main constructor of the class. And you can see why if other constructors didn't call it, then these parameters wouldn't get passed, and there wouldn't be useful values for them to apply down here in the body of the class. So obviously, in order to get those parameters bound, arguments need to be passed to them, either directly by someone calling the primary constructor from the outside, or by the constructors of the class itself, the other constructors always calling this. So the rule is you can't call base here. You have to call this if you declare a constructor of your own. But other than that, it's kind of straightforward. Now, there's still a few things that, there are many things actually you can't do with a primary constructor. So we are declaring a constructor for you, but there's currently no way in C# to actually give it a meaningful body. You can't have a body of the primary constructor. If you want to do this, well, you have to fall back and use constructor, old-fashioned constructor syntax. So if you want to validate your arguments and so on, you're kind of out of luck here. We think that this is still common enough that this will help you structure a lot of your code. And probably in a future version of C#, we'll think of a good syntax to let you run some code after the primary constructor has been called to finish initialization and validation. All right. So that's what I wanted to show you in terms of primary constructors. And then I'll get onto something on the screen that's also a little ugly, that we have kind of gotten used to maybe, but that could definitely be nicer. And I may possibly be fighting a little bit for the intelligence of Visual Studio not to give this story away, but I'll try my best. So I'm currently taking an array of grades here, and in order to pass them in, I do that in two places. Here, I'm creating a new array using the dedicated syntax for creating a new array. I can do it pretty tersely. I don't have to say the type anymore. It's pretty neat like that. but it's array specific, right? And down here, I happen to know, or an analyzer happened to tell me that I shouldn't just create an empty array and parse it or pass it along, because then I'll be allocating empty arrays needlessly. I should go to array and get .empty, and then I will get the canonical empty array. Okay, so great. But what if I want to use list instead? Okay, let's do list of grade. List of grade. Shouldn't change much, right? But now, of course, the array specific syntax doesn't work anymore. Well, I can new up a list. Again, I don't even have to say the type that I'm newing up. It can be target type by where I'm passing it to, but still, it's different syntax. And of course, this array.empty doesn't work anymore. I could try list.empty, but there isn't one. There isn't a list of decimal empty as well, because list instances are mutable in their length, and they shouldn't be a specific empty one for that. But you have to think in order to realize that, oh, I should in fact new up a list here as well. I can new up an empty one, and it's pretty terse, but again, it's different syntax. And of course, if I change my mind, so what I'm using up here is the collection initializer feature that we added in C#3 many years ago. That what it actually does is it calls add on the newly created list for every element here. It adds that and adds that. So it creates it and then mutates it. But hey, what if I have an immutable data type of some sort, like immutable array here of grade? What happens then? Well, it looks like it kind of just works, but that's actually that's a very, very dangerous illusion here. Immutable array also has a nice add method. But because it's immutable, what the add method on immutable array does is it takes an element and then creates a new immutable array that's one element bigger that has the added element in it and returns it to you. Well, guess what? Collection initializers don't know. They don't know about this. They don't know that add doesn't add, and they don't know to get the result of that and pass the thing along. And even if they did, it would be very inefficient. We'd be allocating arrays that were one bigger for every add that we did. It would be hopelessly inefficient. So this is bad. And the lesson really is collection creation is a mess, and we can do so much better. In fact, all this like deliberation that I've done in front of you here now, I shouldn't have to do any of that. I shouldn't have to think about this so much. I should just have a way to create a collection in C# that works every time. And now we do. And that new syntax is what we call collection expressions. So you can simply say, open square bracket, then some elements with commas between them, and close square bracket. And you can say that regardless of what type you're creating. So down here, I would simply just give you an empty one. And as long as there's a target type, as long as you're passing it to something or assigning it to something, then we'll create a thing of that type. Okay? So immutable array, it'll just work. How? You don't need to know. What you need to know is that we'll do it in an efficient way. The compiler, I'm going to tell you anyway. It's not that it's none of your business. It's just that in the moment, the idea with collection expressions is that you don't have to think about it. You don't have to worry about it. The compiler will find the efficient way of creating your collection. One way for it to do that is for the collection, let's see if we can find this here, is for the collection to tell you how it wants to be created by collection expressions. That took some time. There we go. Let's see if we can find the attributes on here. There we go. See, it has a new attribute called collection builder, and it says if a collection expression is ever going to build an immutable array, it should go to the type immutable array and call the create method. Oh, so a collection can explicitly specify how it wants to be built in a way that it knows is efficient. Okay. Other collections, let's just pretend list is one of those, can still fall back on, let's say that they don't have that. Well, if they have common collection methods like add or add range, ensure capacity, all those things, the compiler will look for those and it'll pick the one that it deems the most efficient for creating this particular kind of collection. And of course, this works for arrays as well. The compiler just special cases arrays and spans and a few other types and just knows exactly how to create them. And actually, it goes a little further than that. So some of the common, in general here, we've just been saying if there's a concrete target type, then we can create one of those. But it actually goes a little bit further where an interface could choose to also put that attribute on and say which kind of instance, where are you going to go to create some concrete instance of this interface. And some of the interfaces, the common collection interfaces, like IEnumerable, for instance, we actually special case as well and say, hey, we will create you something. We're not going to tell you what it is, but it's going to be a really efficient, robust implementation of the IEnumerable interface. Maybe we'll use a class that's already in the core libraries. Maybe the compiler will generate one that fits your exact elements. We will do whatever we want to that's the most efficient, and you don't have to worry about it. You can just lean back and say, I got the simplest syntax. I got a unified syntax across all my collection types, and the compiler made it as efficient as I would have written it, possibly even more efficient, because it can afford to do gnarly stuff that would make for ugly code in your specific source context, right? Code you wouldn't want to have to maintain yourself. So we think this kind of hits a really sweet spot. I'm not going to keep it IEnumerable because then the list patterns down there don't work. But let's actually use iList here as an example. Still not enough. Okay, let me just use list. There we are. Okay, so a few more things about the collection expression syntax itself. So we have single elements here, but you can also spread in other things. Let's say that I'm not entirely happy with my grade point average here. I could go and see if there are some other grades out there that I can. Let's get some better intelligence here. Well, looks like my colleague Dustin has his grades up there. Let's pick those, and I can spread them in by using the ... syntax here. So this is what we call a spread element. You might recognize that it's familiar with our range syntax. And this means take all the elements of that other collection and add them at this point here in the order they appear into the new collection. So you can spread in as many things as you want. And they'll just come in the order that you put them. So it's a pretty flexible syntax. You'll notice if you've been looking at my little pattern match down here with list patterns, that the syntax is very reminiscent. This is not an accident, right? We like that the construction syntax and the pattern matching syntax of a given kind of value, that they match up. And usually, like in most cases in the past, we've started out with a construction syntax and then we made the pattern match, the pattern syntax look similar. In this case, it was the other way around. We had the list patterns already last year, and now we've expanded to actually have a construction syntax that matches. So that's what's there for now. There are a few things that we didn't do and that we probably will get to, but we want to get some more user feedback and we want to think a little bit more about it before we go there. One question is, if there isn't a target type for a collection expression, if you just say var x equals and then a collection expression, what happens? At this point, that's just an error. They don't have an inherent type. And that's because it's actually it's a pretty difficult decision. What would be a good a good default type for us to pick for you. So we want to make sure that we make the right choice, or possibly arrive at the conclusion that there is no right choice and we shouldn't allow it in the general case. But that's something that needs another round of deliberation with the C# design team, and then come C# 13, we can have made a decision on that. Another common thing that's similar to collections is dictionaries, and we also want to make dictionary literals. It might look something like X colon or something. For each element, we would put a key colon value, and you could also spread in other dictionaries and so on. This is a syntax that we are not supporting yet, and there are lots of detailed design decisions we haven't made around that. But the intention is that we'll get there as well. So that's collection expressions for you. If I was to guess, I would think that this is probably the feature that will have the most impact on people's source code. Primary constructors, great. If you have things like dependency injection, for instance, this is going to be sweet. But collection expressions, they're really like, there's so many places in most people's code where you are creating some kind of collection with elements, and all of those places can become nicer. So this is really impactful, I think, and it's going to make all C# code nicer forever. So I'm really, really proud of this one. I'm looking forward to seeing where it goes. Those are the two main features that I think, there are several others, but they're smaller, and we're not going to go into the details of it here today. But again, go back to the docs page I showed you before, and you can dive into the ones you're interested in. Now, there were some other things that we wanted to do in this cycle and that we ended up not being able to get to, and that are likely to make it in the next release. And one of the ones that I really like, and I'm kind of sad that we didn't get to, is the one that we call field access in auto properties. So I'm going to show you the feature, and then I'm going to talk a little bit about why we didn't get to it. So the feature is going to give you a lot of squiggles here because it doesn't work, but bear with me. So the idea is, an auto property is great. It declares its own backing field, and it implements the getter and setter trivially to access that backing field to either read it or write it. Okay, that's great. And we made auto properties a little more expressive over the years. They can be getter only or get init. They can be initialized in more cases, and but by and large, there's still a cliff that you fall off if you want to do any non-trivial logic in the accessors itself. I'm getting a string in here. If I just want to trim the white space off of the ends of it, I can't use an auto property anymore. And I'm essentially, I fall off the cliff and I have to write it all manually. And the field access feature is there to remove that cliff and to smooth out that scenario. So the idea of the field access feature is that you can, in fact, provide a body in an auto property. And so let's say I want to write my own version of the setter. And what the setter would normally do is it would say that the backing field is assigned the value that comes in. So we want to add an extra kind of magic variable in scope here in the accesses called field, and that's a reference to the backing field. And you can do things with it like assign to it. So the standard behavior of the setter of an auto property is this, right? You just assign value to field. But now we could do more things. We could say value.trim to get rid of that white space, for instance. And now we've written our own. I don't have to implement the getter as well, but I can if I want to. And the backing field is, even if I do, if I did, it would be sort of indistinguishable from a non-auto property, except that the use of field in here still instructs the compiler that this is still an auto property. They're still using the backing field, even if they're not getting their accesses generated. So this is still an auto property. I'm still going to give them a backing field. So this feels like a very nice way to smooth out the cliff and avoid having to rewrite a bunch of your code, even if you have helpers in Visual Studio to do it for you. Keep your code simpler. So that's the feature. The problem with the feature, and the reason we didn't add it, is that in certain cases, this could be a breaking change. So if you had anything in scope out here, let's say you had just a private field, string field here, a field called field, then this bit here means something today. So you can write a property today that is correct and that has the word field in it in this position here. And we could say that if there's something in scope called field, then we'll pick that, and only if there isn't will we use the special meaning of field. But that's not really very nice. That's not a nice language design, right? Because now forevermore in C#, like 20 years from now, if somebody happens to introduce something called field somewhere in scope of your property, then it'll change the meaning of your property. They will have spooky action at a distance, essentially. That's a very brittle kind of semantics, right? And we would do that only to protect quite, there's going to be some, but a few number of existing pieces of code. So I bet that most people who have the existing code would happily, take some help that we would offer them to change their code a little bit to be robust, to maybe change it to say this.field or this.field or something like that in order to avoid the breaking change. So this triggered a discussion that can we start making slight breaking changes in C#? Nothing major, not like removing features or making whole swaths of syntax illegal or something like that. Nothing like that. But if we make tiny breaking changes that we expect will only hit very few lines of code and mostly none in most people's projects, then maybe there's another way here where we can offer you when you get the new SDK, the new compiler that knows about the next language version, but before you even go to the next language version, before you go to C# 13 or whatever, we'll tell you now because you're using the new compiler with an old language version, we can tell you, hey, actually this bit here, this field here, this is going to break. This is going to mean something else. Here's a fixer. It's a code fixer that can quickly rewrite your code very locally and with a tiny little edit like that one. And you can opt to do it everywhere in your code and just get this over with. It doesn't materially change it doesn't change the meaning of the code at all, and it doesn't materially change the look of your code either. It's not going to make your code not feel like your code. It's just going to fix this little thing up for you to do the thing you would already have written if the feature had already been there when you wrote it, so to speak. Right? So we're playing with, can we do something there? But we didn't have time to fully design and vet a scheme for handling breaking changes in time for C# 12. So we chose, instead of having an inferior design of this feature, we chose to give it one more turn of the crank, try to work out if we can do it the right way and use it as kind of the canary in the coal mine for a feature that lets us do very controlled, very limited breaking changes in C# going forward with good tool support for having everyone move forward with confidence. And so expect to see more from us on this and probably some early preview activity here so that we can try out a scheme and get it vetted with customers. All right. So with that, we have about 10 minutes left, and I am going to go and show you some slides for the rest of this time. So yes, it's slides, but we're going to show some code. I want now to go into story mode because this is a feature that the feature I'm going to talk about has more work on it still before it can become reality. And it'll probably change a lot, and it very well may not make C# 13. But I still want to kind of put it on your brains to show an example of how we sometimes do longer, bigger story arc things where we have features that we evolve over multiple years in order to kind of hit the right semantics and do something more fundamental, something that really changes your expressiveness in C#. And the feature we're going to talk about is called extensions. So here's the general idea. Think of an extension as a very fancy alias, using alias. Okay, but so essentially we're saying here that dataset is an alias for dataset of T is an alias for dictionary of string and T. Okay. So it's like an alias that can do more things. It can have an accessibility, so you can actually, you don't have to declare it in every file. In fact, not even in every project. You can have it. It's a real type declaration, and you can export it as part of your surface area in a given library. So it's a real type declaration. It can be generic, unlike aliases today. It can have constraints. It can have references, direct references to other types. You don't have to give the full path to it. It's not part of like the using preamble that doesn't know your other usings. And furthermore, it can have a body, which we'll get into in a little bit, what can be in that body. Okay, so fancy alias. Got it. All right? With me so far? Now let's see what you can do with that. First, let's just say that this explicit extension here, that the explicit is there because we also want to have implicit extensions. And we're going to get back to the difference later, but I think explicit should probably be the default, so I'm going to not write it from now on. Okay, this is how we're going to see extension declarations going forward. So the idea of an extension. Here we have a little example. I have a display method. It takes a string that's supposed to represent some JSON. Presumably, it parses it and does stuff with it. And so I can call it with like a raw string literal, for instance, that has some JSON in it. Nice. Okay. But maybe I want to indicate that the string is supposed to be JSON. So let's introduce just a trivial alias called JSON string for string. And then I can say JSON string here to indicate that this is actually supposed to be JSON. Right now, this is just a hint to the user. There's no semantic difference, but because the extension itself is public, that the alias isn't elided when somebody looks at your library. They will still see JSON string as the type here. So this is a useful kind of extra little encode comment, if you will. But that's the least of it. Now I'm going to put something in the body of this alias. I'm going to say when a string is viewed as a JSON string, when I use this alias for string, then I'm going to give you some extra function members. I can't put extra data on there. That would be weird because the string is still a string, but I can give you some things, some function members that make sense in the particular context that this alias is for. In this case, being a JSON string, it makes sense that you would offer an instance method called parse that parses the string as JSON and gives you back something. Let's call it data object, like a dictionary containing the data that was in the JSON string. Okay, now that means that the method that takes a JSON string, on top of just signaling that it should be JSON, it can actually now use the functionality that's associated with a JSON string. It can now call JSON.parse as part of its functionality. So you can see how this starts to get kind of useful. And of course, because you explicitly have to take your string and view it as a JSON string in order to get that parse method, you could have other extensions on string, like say XML string, that even do something similar. And depending on whether you view your string as an XML string or as a JSON string, they will have different parse methods that do different things. So functionality coupled with your aliases. Got it? Let's look at another example. Let's assume again that we have data object that's some kind of dictionary for representing semi-structured data like JSON. Now, what I want is, when I'm looking at my semi-structured data, I would love to have some sort of like a strongly typed veneer, a kind of like again, a view through which I can treat it as if it was a strongly typed customer object. So I can do it like this. I put an extension on it. I give it some strongly typed properties, and those properties just call into the dictionary part and do whatever conversions and stuff is needed. And of course, if I take a data object and view it as a customer, and it wasn't actually, like it didn't have these properties, well, then then you get runtime exceptions from this. That's fine, right? Yeah, I mistyped it. Oh, too bad. But, in the meantime, I get, if I do view it as a customer, I get IntelliSense and type checking on all my usage of it. I get strongly typed things back that I can directly use instead of having to decode themselves, right? And I could have multiple different extensions on data object to represent different shapes of data, each of them doing their own translation and encoding their own assumptions about what is actually in the underlying data. So this is another nice way that you can use these explicit extensions to model things. But you might have wondered, he's using the term extension all the time. Does this have something to do with extension methods? And it hasn't fully yet, but it's going to. Okay, because now we're going to get to implicit extensions. So here's an implicit extension. And an implicit extension is the idea that it's an extension just like before. We call it maybe JSON object. So that's an extension of data object with some JSON specific behavior. But because it's implicit, now it means that it would automatically apply to data object whenever the JSON object is in scope, whenever it's being used, for instance. So now it's all of a sudden it's exactly like extension methods in that the members in JSON object are available to all data objects. Right, so we're importing JSON object. That means we're enhancing data object itself with new function members. And that can be instance methods like this, just like extension methods today. So now data object will have a toJSON. And you can see that down here. If I send something as data object, because JSON object is in scope, because these extensions are imported, now I can call toJSON on it. That's just like an extension method. But I can also have a static method and call that in a receive method, for instance, directly on data object. I've added an extension static method, and you can imagine extension properties, extension operators, extension indexes, whatever you want to imagine here. And perhaps we could even go so far as allowing extension to implement an extra interface on behalf of the underlying type. This is kind of like out there. We don't know if we can get this to work on the current runtime or what we should do about this, but wouldn't it be cool if I could use that to adapt data objects to a framework that I didn't know about that uses this interface as its kind of exchange type, if you will. So I could use an implicit extension to get extension interfaces. And then the extension would say how to implement the method that the members that this interface requires. So that's kind of like the vision for extensions. It might, again, as I said before, it might morph a lot, but I think eventually we will have something that addresses some of these data modeling scenarios and addresses essentially the extension everything by allowing other things and extension methods to extend your objects. And with that, we're at the end of the talk. I want to say thank you very much for listening. I look forward to your questions. Have a great rest of your conference and see you next time. Bye.